Hello class, we're going to do one more video. I'm going to introduce the logarithmic derivative. We'll leave the more complicated examples and things we can do with this for a little bit later. We'll do that next week. So let's just start with this derivative rule. If you guys are interested in derivation of this, we cannot quite do it yet. In order to derive this rule, we need implicit differentiation, and we haven't covered that yet. So for now, you guys are going to have to believe me when I tell you that the rule for the natural log of x is just 1 over x, okay? We take the derivative of natural log of x, we just get 1 over x. And so this rule is quite straightforward as well. It really just says, hey, whatever's inside your log, take 1 over that thing. So we'll do a couple examples of this. The first one I have here is going to be really straightforward for the derivative part, but we're going to use this to calculate something. We're going to use this formula to find the slope of the tangent line to the curve y equals ln x at x equal 1. So we have y is equal to ln x, and that means that y prime, the derivative of it, well, we'll use this rule above, is 1 over x. Okay? If I evaluate y prime when x is equal to 1, I'm going to get 1 over 1, and that's going to equal 1. That's the slope of our tangent line. We also need a y1, so remember that your y1 or your y0, just depending on which formulation you're talking about, is going to be the original function evaluated at that value. In our case, we're really talking about x0 being 1, so we could call this x0, and then this is x0. And so we're going to take the natural log of 1. If you know a little something from your pre-calc days, you should know that the natural log of 1 is 0. Why is it 0? This has to do with the fact that if you take any number to the 0th power, you always get 1. So putting this all together, we have y minus y1 equals m x minus x1. Or, you know what, let me use the not formulation since that's what I used above. And we're going to basically write the formula where y naught is 0, my m is 1, my x naught is, my x naught is 1. And so really the slope of my tangent line is y equals x minus 1. Okay, so really straightforward example of using this rule. We'll do one involving some chain rule in a moment, but I just wanted to start by reminding everybody that we do have some application questions that'll come up where you may be required to find the slope of a tangent line. We hadn't done that in a while, so I wanted to include one here just to remind everybody not to forget these kind of details around the edges of the derivatives we've been doing. Let's do a chain rule though. So I have the natural log of the sine of x, and I would like to find the derivative of that. And so the rule says, I'll write it one more time. The rule says that if we take the natural log of x and we take its derivative, we get 1 over x. And so if I have the natural log of sine of x, I'm going to get 1 over sine x. Okay? I'm going to take 1 over whatever the inside of my log is. Now, I also need to do the derivative with respect to x of sine x because of chain rule, right? So here's the derivative of my outside, here's the derivative of my inside, and so we need to put this all together. The derivative of sine is cos, so this is really cos x over sine x. And if you know a little bit about your trig, that's actually cotan. Okay, so it turns out that the derivative with respect to x, the natural log of sine of x, is actually equal to cotan of x, okay? Which is quite a nice result. Oops. This video is feeling a little short, so I will add another problem since I have some space here. So I'm going to shrink this down and try to fit it on the page. If you don't have space, you may want to grab a separate sheet of paper, pause the video. But let's, oh, you know what? I've got plenty of space. I'll just do it over here. Let's do another example. I'll call it example 48. And so let's do the derivative with respect to x of, let's go x squared plus 1 times the natural log of, let's do something like tan 2x. Okay. Zoom that in a little bit. I want you guys to notice this is a product rule. And then inside the product rule, we have a chain rule, and inside that chain rule is another chain rule, right? So this is definitely deep into what I would call an intermediate derivative. We're getting to the point where we're layering, 3 or more rules. Advanced would be when you're doing some really, really hard stuff, like when we start doing like inverse trig functions of a logarithm times something else, and we're doing like 5 rules at once, right? So let's try this one. My f of x is x squared plus 1. My f prime of x is 2x. My g of x is the natural log of tan of 2x. And I'm going to need to do a little bit of work to the side here to figure out what that derivative is. Okay, the natural log rule says, hey, take 1 over whatever your argument is. So, sorry, this isn't tan x, it's tan 2x. And 2x. And then, because of chain rule, I need to multiply that by the derivative with respect to x, tan of 2x. The derivative of tan is something you guys should know. That is going to give us secant squared 2x. But we got to do chain rule again because now we have an inside that looks like 2x. So the last layer of chain rule is 2x. And so secant squared 2x over tan 2x times 2. And so rather than write it like that, I'm going to go ahead and bring this up like this. Okay? And so this is my g prime. Over here, when I write my g prime, can I simplify this? Let's see. So tan is sine over cosine. So 1 over tan is cosine over sine. So this is 2. Secant is 1 over cosine. So this is 2 times 1 over cos squared of 2x times tan, which is sine over cos, but it's 1 over tan, which is really cotan. So this is cos of 2x over sine of 2x. So I do believe we can do some simplifications here. Cancel that out a little bit. So we could write this as 1 over cos is secant. 1 over sine is cosecant. So this is actually 2 secant 2x cosecant 2x. That's not necessarily too much better. I think we went from complicated in terms of fractions to being complicated in terms of trig functions, but depending on who you are, you may or may not like that more. And then we'll set up our product rule. So I'm going to do f prime times g and f times g prime. So my final answer here, following this guy, is going to be 2x natural log of tan of 2x plus x squared plus 1 times, I'm going to bring the 2 in front, times 2 times secant 2x times cosecant 2x. Okay. And as far as I'm aware, there's nothing nicely that can be done with that to make this any simpler. If it was sine and cosine, we could use a double angle or something over here on the edge, but secant and cosecant, better to just leave it like that, okay? So that's kind of a deeper cut. You guys should try some of the homework, figure out where you're struggling, what you're confused by, and bring those questions to me on class on Monday, okay? And if you have anything else you want to ask, you can also bring those on Monday. On Monday, we'll do the next page, which is going to talk about how, sorry, not this one. We're going to talk about logarithmic differentiation, okay? So I'll see you guys on Monday. Let me know if you have questions. This will be the last video in the series that I'm requiring you to do video notes on for credit. So if you have officially gotten to this point, you are done with the assignment. You're welcome to take scans of all your notes and submit that on Canvas for credit, okay? I'll see everybody next week. I hope you have a good weekend.